In this video, we're going to talk about thermal energy and thermal equilibrium. Thermal energy is the total kinetic energy of all particles in a substance that has a temperature T, contains n number of atoms or molecules, and is in a solid, liquid, gas, or plasma state of matter. Thermal equilibrium is all particles are at the same kinetic energy of motion. Thus, the substance is at the same temperature everywhere. So in order to study thermal energy and thermal equilibrium, you need to understand particle motion, transfer of energy, heat, and then speeds of particles and the same speed of the particles, or they're in an equilibrium state. Let's first look at thermal energy. Thermal energy, the first thing you need to be aware of is we're talking about the total kinetic energy of all the particles. So let's go look at an example. So down here on the left-hand side, middle and right-hand side, we are looking at two boxes that contain the equal same number of atoms. So N is the same. Now the one box on the left has very hot particles, so these particles are moving very fast. So I will give them random directions, and they have big arrows indicating that they're moving very fast. Now the next box over has a cooler temperature, so I'm just going to give them random motions, but smaller arrows to indicate that they're not moving as fast. So now thermal energy is a measure of the motion, the total motion of all the particles in the box. So the total energy is given by a sum of the number of particles in the box and the temperature. And for nice, easy thinking, we're only going to be looking at a gas state. So we're going to be looking at like maybe a hot vapor of water or a cooler vapor of water. So we're not going to get into this plasma state. Let's avoid plasmas and look very simply and focus on mainly number and temperature. So we have equal numbers in the boxes, but we have two different temperatures. And because the box with the hotter particles they're moving faster, they have the higher speeds, and the temperature is higher, they're going to have a higher total kinetic energy. So their thermal energy is going to be higher than the one in the box on the right, because these particles, even though they have the same number of particles, they're not moving as fast. And that temperature is lower. And so since the temperature is lower, the total sum will be lower. Therefore, the thermal energy, which is the total sum, which will be lower. Now, when we put the hot box next to the cold box so they become in contact, we have what's called heat transfer. And heat always transfers from the hot side to the cold side. It never goes the other way. It goes hot to cold. So what you're trying to do is you have these fast-moving particles, you have these slower-moving particles. You're going to slow down the fast-moving particles, and you're going to increase the speed of the slower-moving particles until all the particles are moving at the exact same speed. They're moving in random directions, so I'm just going to give them middle length arrows, and in random directions. And this will indicate that they're going all at the exact same speed. So you notice they colored them all at the same color, and they have random directions and these middle length arrows. So indicating that this is some kind of medium temperature. So somewhere in the middle. So we'll put mid for middle. We have still the same number of particles, but we have dropped the temperature so that the speed of the particles are about the same. Therefore, since all the particles in both boxes are moving at the same speed, we are in a state here of thermal equilibrium. And the temperature in both boxes is exactly the same because the particle speeds are exactly the same. So this is what we mean by thermal energy and thermal equilibrium.